Welcome to the video about computer memory. My name is Hafiz and I'm a lead engineer in profession. Let's see what is this computer memories. A computer is a device that is electronic and it accepts data, it processes that data and gives an output. This is the basic idea behind the computer. Sometimes to process the data, it has to be stored somewhere in your computer. Also, some data should be stored for future processing, and also some will be stored after processing. If you take this computer memory, it is just like the human brain. It is used to store this data or instructions. This can store both input data and output data of the computer. If you take this computer memory, it can be divided into two parts. One is primary memory, or we call it as main memory, and the next one is secondary memory, which is we call as auxiliary memory. Physically, computer memory consists of millions of memory cells. So memory cell is an electronic circuit that can store 1 bit of binary information, and it must also have logic 1 and zeros. So 1 is to set data and 0 is to reset the memory cell. So this memories are consist millions of these small memory cells. Now let's see about the primary memory in a computer. This primary memory or main memory holds the data that is currently being processed by the processor. This has a very limited capacity and the data will be lost when the power supply is disconnected from the computer. Primary memory devices are built using semiconductors, and mainly it focuses on the data that need to be processed immediately. So it can't store forever. I mean, it is just the data will be stored for the time being. This memory is faster than the secondary memory and must needed component for the computer. It actually has to be faster because it is the main source of providing data for the CPU for the processing. So the way the data is getting processed using this memory is something separate. So it's a separate topic. A lot of things are going on. There are queues, scheduling algorithms, and dispatchers, and etc. So I'm not going to touch that part in this video. Otherwise, it will become more lengthy. We have these three different types of primary memory in our computers. One is RAM or random access memory. The other one is ROM, read-only memory, and we have the cache memory. So now let's see one by one what are these. Random access memory is the internal memory of the central processing unit or the CPU. This is a read and write memory that storing data and instructions. Since this is a primary memory, the data will be lost when the power goes off, as I already mentioned. Based on its memory capacity and physical size, we can segregate this into two different types. One is static RAM, SRAM. The other one is dynamic RAM or DRAM. Next, we'll see what is read-only memory or ROM. As the name suggests, this memory is only readable and we can't write on this memory. In random access memory, we learned that it can both read and write. The ROM devices can store data until its lifespan. But in RAM, it is just storing data until the time being, until the CPU process its data. Computers are having an inbuilt ROM that has programs to boot your computer. So when you're booting your computer, you need a certain set of programs to load the operating system. It has things like MBR, BIOS kind of things. So that will access the operating system from your hard disk when you press the power button. So this inbuilt ROM helps in the boot sequence. This type of ROM or read-only memory is available not only in computers, but also you can find these things in washing machine, microwave ovens, and etc. There are multiple types of ROMs available. So one is masked ROM, MROM. The next one is programmable ROM. Third one is erasable and programmable read-only memory. The final one is electrically erasable and programmable read-only memory. So those are the 4 different types of ROMs that we are having. One thing to keep in mind, the term read-only is in here doesn't exactly mean it is the device is not writable at all. Obviously, it should at least written once to read something out of it, right? So for example, if you take a CD-ROM, it also kind of a read-only memory, but it is still a secondary memory. So initially it doesn't have any data, but later you have to write something, maybe some movies or songs or whatever. The way the ROMs are getting written is significant in here. The way it is getting written is more important in here. The technology behind writing data to this ROM doesn't allow us to easily modify these data. So the technology behind it prevents us from easily modifying the data on these memories. So that's the purpose of ROM. Next we have cache memory. This is a supplementary memory that temporarily storing data for quick accessing. This is a volatile memory, like same as the RAM, and provides high speed of data access. Software engineers are utilizing these cache memory when developing complex software systems to store frequently used data. By that, this will increase the performance of the system and helps to reduce the resource utilizations that affect the cost of the system. So those are some advantage of using this cache memory. Cache memory is created using various tools and plugins. This will allocate a small memory portion from the RAM or the hard disk for the purpose. We just take a small portion from the random access memory or the virtual memory, which is the hard disk, and we are allocating it as a cache memory using various plugins and tools. Next, we discuss about the secondary memory. So first we discussed about the primary memory, RAM, ROM, and cache memory. So here we are going to discuss the secondary memory. These are external memory that we plug into our computers. These are non-volatile and non-permanent. Secondary memory is bit sluggish compared to the primary memory. CPU will not directly access these memory units. Rather, there will be programs like dispatcher. It's a kind of a program that reads data from these memory into the queues and from queue to CPUs. So that's a different area, the different logic behind that. There are multiple algorithms are getting used in operating system in a computer. So these are some examples of secondary memory: CD-ROM, DVD, pen drives. So we know that we mostly use these things. The next we are going to talk about the memory measurement units. So there are certain set of units that we use to measure these memory. We use memory units to measure the capacity of the data that can be stored in a memory device. either primary, secondary, or cache. Following are some units you can see here that are used to measure the size of the data. The first we have the bit, is the smallest unit. We call it as binary digit. So this is this basically comes in zeros and one. In electronic, 0 means it's passive and 1 means it's active. The other one is nibble. So 4 bits are equal to 1 nibble. It's a group of bits. So if you take 4 bits together, it will become 1 nibble. Byte. So 1 byte is equal to 8 bits, or we can say 1 byte is equal to 2 nibbles. So byte is the smallest unit to represent a letter. Letters like alphabet letter or whatever the letters that we have in our oral communication or written communication. So next is a familiar for us. So 1 kilobyte is equal to 1024 bytes, and 1 megabyte is equal to 1024 kilobytes. 1 gigabyte, or we call it at 1 gigs, is equal to 1024 megabytes. 1 terabyte is equal to 1024 gigabyte. 1 petabyte is equal to 1024 terabytes. So those days, like around 20-30 years back, having 1 MB is a big challenge. It's a big capacity by looking at the technology and data that we had those days. But today, 1 terabyte is not enough for us to store all our data, movies, songs, those things. So it's 1 TB is not enough for us. So that's how the technology has got evolved. That's all about I want to talk in this video. We'll meet again in the next video. Thank you.